Hello Pre-Calc PC. Today we are talking about polar coordinates part 2. Yesterday we learned how to convert from polar form to rectangular form, but today we're going to do the opposite. So we're going to move from rectangular to polar, which is a bit more complicated. So let's take a look. 3 comma 4, that's my point, as x comma y. And I'm going to go ahead and draw on a triangle. This is theta, which is what I'm trying to find. This is my radius, which I'm trying to find. And my 3 is going to go here, and my 4 is going to go here. Well, I think already based on our knowledge of trig and geometry, we should be able to figure out what r and theta is. Radius, we can just go ahead and do our good old pal Pythagorean Theorem. So 3 squared plus 4 squared equals r squared. And that'll be 9 plus 16. 25, and the radius is just 5. All right, and what we can use for theta is opposite over adjacent, or just tangent. So tangent of theta is 4/3, and we're going to do this in radians, so let's take our calculator and switch to radian mode. Most of the time you will have problems that you can identify the tangent from the unit circle, but 4/3 is not one of them. So we'll just do, in order to find theta, we'll take inverse tangent of both sides, 4/3. Okay, that's how we'll find our angle. And you should get a 0.927 radians. So if you have a degree symbol, we assume we're in degrees. If you don't have a degree symbol, it's assumed you're in radians. So make sure that if you need a degree symbol, you have it, because again, otherwise the assumption would be that you're in radians. So this is theta, and our point would be 5, 0.927. All right, so key concepts. Well, to find the radius, if you look, this was just our x and our y. So the big one is that x squared plus y squared equals the radius squared. That's just our Pythagorean theorem. And then our other would be that the tangent of theta is equal to y over x. Okay, they're not quite as pretty as our conversions that we used yesterday, but they will do the job. All right, so these are ones you will have to know. Okay, so this is a little trickier than yesterday because the quadrant that you're in really matters. Let's go ahead and write down our pi over 6 and pi over 3 just to help you with your unit circle. Pi over 4, we should know. Okay, so again, you're dealing with xy, and we are going to convert to r comma theta. So root 3 comma 1. Well, both of those are positives, so you would be in quadrant 1 here. And if you want to actually draw the triangle, you can, or you can just use the formulas that we just talked about. I usually just plot where the point would be. I'm in quadrant 1, and then I just do the formulas. I don't actually draw a triangle usually. So x squared plus y squared is equal to r squared. So we'll just plug it in. Root 3 squared plus 1 squared equals r squared. That's going to be a 3 plus a 1 is 4. And you should get a radius of 2. All right, and then I have tangent of theta is equal to my y over my x. Okay, so here's where we should be able to do this without a calculator. In fact, we're going to be able to do 1 through 5 without a calculator because all of those are going to turn out to have angles from our unit circle that we should recognize. Tangent is y over x. So if we come up here and look at pi over 6, okay, or we could say sine over cosine. When we take 1/2 divided by root 3 over 2, the 2's would cancel and you would just have 1 over root 3. This means, oops, that we are dealing with pi over 6. So theta is just pi over 6. Now, here's where you need to check. Because we are in quadrant 1, rectangular, so we still need to be in quadrant 1 for polar. So check, is pi over 6 in quadrant 1? Yes, it is. So 2 comma pi over 6 is our answer. Okay. And it is in quadrant 1. Okay. With these types of problems, once you find your point, you must always check to make sure it's in the correct quadrant. Okay, and we'll get to why that happens or doesn't happen when we get to one like that. Okay. All right, 0, 2. This isn't really on a quadrant. This is on the y-axis, right? Well, whenever you have a point that's on the x or y-axis, your job becomes infinitely easier because we can identify what angle we are at right now. Straight up at 0, 2, that's at pi over 2. The radius is just how far away you are from the pole or the origin, which if we're at 0, 2, you are 2 away from the pole. So we do not need to use our formulas. We can just say, well, if we want r comma theta, the radius is 2 and the theta is at pi over 2. Okay, again, just to re-explain that, 0, 2 is straight up on the y-axis. We know what angle that's at. That's pi over 2. Unlike, for example, in number 1, like you're not sure what angle this is, so you have to figure it out. Okay, and we know that the radius is 2 because it's just 2 straight up. Whereas over here, we didn't know what r was. We actually had to calculate it. All right, next one, -2 to root 3. Okay, again, this is rectangular, negative x, positive y. So I'm over here in quadrant 2. Okay, let's find the radius. X squared plus y squared equals r squared. That's a 4 plus, careful with this one, you got to square the 2 and the root 3. That would be 4 times 3 equals r squared. 4 plus 12 is 16. And your radius is 4. Okay, theta. We say tangent of theta is equal to y over x, 2 root 3 over -2. Okay, let's simplify that. That's just going to be negative. Okay, so again, tangent is sine over cosine or y over x. So by looking, what's nice about having these points here is that visually you can see tangent more easily. Root 3 over 1, that would be the tangent of pi over 3. Our tangent is a negative pi over 3. So what that just means is that instead of our angle being pi over 3, our angle is really negative pi over 3, okay, because the tangent is negative. Okay, now here's where the issue is. Negative pi over 3 is in quadrant 4. I need to be in quadrant 2. All right, so what it is suggested that you do, and we'll get to an alternative in a minute, is in order to get from negative pi over 3 to that guy over there, all you have to do is add pi. Because essentially you need to get 180 degrees around. So negative pi over 3 plus pi would just be 2 pi over 3. Okay, again, we were in the wrong quadrant, so we needed to find the pi over 3 angle in the correct quadrant. So here's option 1. Now, option 2 is the people who say, well, wait a minute, why can't I just keep the negative pi over 3 and change my radius to a negative so I can make it shoot through to the other side? If you want to do that, if you want to call this -4 negative pi over 3, that's fine. They are the same thing. That being said, it is going to get to a point when we get to 8.3 where you must have your angle as a positive and in the correct quadrant. So this idea of adding a pi or sometimes a 2 pi is going to be important. Okay, so this is something you should be able to practice. You should be able to get this point even if you prefer using them, but either is fine. Okay. All right, next, -1, quadrant 3. Okay. R squared is equal to x squared plus y squared. or x squared plus y squared equals r squared. So go ahead and plug that in. Please show the work, even if you can do this in your head. We should get our radius is root 2. Tangent of theta equals y over x. Just 1. This should be our favorite angle. This means that when we divided the sine and the cosine, they were the same thing, so they divided to 1. That means we must be at pi over 4. All right, however, here's the problem. Pi over 4 is over here in quadrant 1. So we need to, again, add our pi to move over to quadrant 3. So if I add pi, I will now have pi over 4. Okay, now again, many of you are going to say, well, I'm just going to make the radius negative. Again, that's okay for now, but it won't be okay later because you'll need to have both a positive radius and a positive angle when we get to complex polar. All right, so the other option would be root 2 over 2, or excuse me, root 2, 5 pi over 4. Either of those is fine. So I want you to look and see when this has happened so far. The issue that we come across is when we need to be in either quadrant 2 or quadrant 3. That's when we have the issue of having to change our angle. All right, so be on the lookout. When you're in quadrant 2 or 3, you are going to need to change your angle. And the reason is that when we find inverse tangent of something, we always find it from quadrant 1 or quadrant 4. So when you do inverse tangent, you're only going to get an angle in one of these two quadrants, 1 or 4. So if you are supposed to be in quadrant 2 or 3, you are going to have to change your angle when you're done. So next we have -8, 0. Again, this is in rectangular form, so you're somewhere over here. This is on the x-axis. Okay, so here's my point at -8, 0. This is one that we don't have to do any calculations for again. You are 8 units from the pole, and this angle over here is pi. So this point is really just 8, pi. R, theta, or some people like to get real cheeky, it's a fun British word, and say, oh, well, guess what? In polar, it's also -8, 0. Haha. Which I mean is true, right? Because 0 would be over here. Let's say you're at 8, and since it's -8, it would make you go over here. So technically, -8, 0 is in polar form as well. I prefer to write it like this, though. Okay, and our last one like this, this is going to be the only one we will have to use our calculator for. Quadrant, -5, 10. This is quadrant 2. This is the danger zone. We will have to change our angle for this one. All right, so r squared is equal to x squared plus y squared. It's going to be, what, 125? And when you square root this, you can either write it as root 125 or this one's a nice one, it's 5 root 5. Tangent of theta is 10 over -5, which is -2. All right, so this is not one that we recognize from root 3 or 1 over root 3 or 1, which are from our main unit circle angles. So we will have to use our calculator for this. Inverse tangent of -2 gives you -1.107. Okay, well, let's think about where that is. -1.107, obviously it is, well, it's in quadrant 4. How do you know it's not in quadrant 3? Well, here's the fast answer. This is pi to go around half the circle. Pi is 3.14, right? 3.14159. If you take pi and divide by 2, that's 1.57. So this guy right here would be like the -1.57. 0.157, and r negative 1.107 isn't quite that big yet. So you are in quadrant 4 for sure. Of course, the issue here is that we don't want to be in quadrant 4, we want to be in quadrant 2. So we will have to add pi to this, and we're just going to do that with our calculator. And you should add, oh, hold on, I don't want that. I want this. You should add actual pi, don't add 3.14. So 2.034. This is the angle that we really want. So 5 root 5, or you could say root 125, 2.034, and that is our quadrant 4. Or quadrant 2, I should say. All right, good time so far. Let's flip to the back. The last thing we're going to do is convert back and forth between rectangular and polar and rectangular, but this time for equations, not for points. Okay, and we're going to look at what a bunch of these equations actually mean over the next couple days. So key ideas is again that x squared plus y squared is equal to r squared. Another key idea that we'll use for conversions are that x equals r cosine theta. This was what we did in our last lesson. And y equals r sine theta. These are the big three that we'll use for converting. All right, so for example, with these three problems that we're going to be doing, we are in rectangular, that's why we have x's and y's, and we want to convert to polar form, meaning when you're done, you should not have x's and y's, you should only have r's and or thetas, and we are going to solve for r. All right, so most people really like these because you get to kind of manipulate these equations. You're looking for something that you can convert to an r or theta. So for example, in number 7, what we can do is pull out a 2. And what that allows us to do is take this x squared plus y squared and change it to an r squared. All right, and now I'm just going ahead and solving for r. So I'll divide by 2 and square root both sides. Make sure that your square root is big enough to keep your 3 over 2 in. And good news for those of you that struggle to remember your plus or minus, when we are in polar form, the plus or minus doesn't matter when we square root both sides. It's okay to have it, but it's actually not necessary because as we saw, we can manipulate our radius to be positive or negative, and either way is fine. So you can have the plus or minus or not when you're in polar form. For rectangular, it is absolutely necessary. All right, so now number 9. Here we have x's and y's. We can go ahead and use our r cosine theta and r sine theta for this one. So x again is just r cosine theta and y is r sine theta. And then what we can do with this one is we can factor out an r. Okay, remember the goal here was to get r by itself. And then finally we can divide by r, or excuse me, divide not by r, by the 3 cosine theta plus 4 sine theta. And that's just a beautiful little equation, isn't it? All right, and then again, we can do something similar for this last one of these. Our y is just r sine theta, but it's being squared. And our x is r cosine theta. Okay, so this one we need to be careful because again, we're trying to get r by itself. When you square, you're squaring both the r and we're squaring the sine theta. The way that we show sine theta squared is like this. All right, so this, the correct notation for that is this. You cannot write it like, whoops. You cannot write it like this because that means you're squaring the theta, not the sine of theta. Don't do that. Okay, so one thing we can do now that you may see is we can actually divide by an r on both sides. And the reason that helps us is it cancels our r there and it gets rid of an r there as well, which gives us this. And then we can just finish by dividing by that sine squared theta. These are problems that as you do more of them, you just kind of see what to do next. And sometimes you kind of have to mess around with it a little bit. They're certainly not as bad as those trig proofs that you guys had to do last year. Okay. Finally, we're going to do the same thing, but this time we're converting to rectangular. Complete the square if necessary. We will have to do that for one. Get excited. All right, so r equals 4. Again, you want to try to find these guys. We don't have anything that's r equals, but what we can do is square both sides and get r squared equals 16. And then r squared, we should know, is just x squared plus y squared. This, which we will talk about tomorrow, is actually the equation of a circle. And it would have a center at 0, 0. And it would have a radius of 4. And that should make sense because look at the original equation. It's telling you the radius is 4. This is standard form for a circle here, which you may recognize from geometry. Okay, now in number 12, we could square both sides again. That would give us r squared for sure. But then we would have a 16 sine squared theta. That doesn't really help us very much. So you have to be kind of strategic in terms of what you're going to do to each side in order to help you use your conversions. Instead of squaring both sides, what I'm going to do is multiply both sides by r. Because what that does is it still gives me my r squared, but it also gives me a 4r sine theta. And the reason that's helpful is because now that can be converted to y. R squared is the same as x squared plus y squared. This is an example of a problem that we will need to complete the square with. We will subtract our 4y over. This is actually going to be another circle, but a circle with a shift that does not have a center at 0, 0. These are the guys I'm going to complete the square with. Okay, so I have x squared plus y squared minus 4y. Divide the negative 4 by 2 and square it. It's going to be a plus 4. And we are going to counteract that by adding 4 on the other side. Okay, so when we were doing vertex form, we did the opposite on the same side, right? We did like plus 4 minus 4, but this time we are going to add 4 to both sides, which is also equivalent to canceling out what we just did. That gives us this. And now this is also an equation of a circle, but your center would be at 0, 2. And your radius would be 2. So this guy right here, that's your radius squared, if you remember from your good old geometry days. All right, last one. Solve for y. Okay, good times. Well, first things first, when in doubt, cross multiply. Okay, or multiply by 3 minus cosine theta on both sides, which doesn't have quite as nice of a ring to it. Okay, so I'm just cross multiplying. And then that r cosine theta, we can change that to an x. Okay, now we need to solve for y, and right now we don't even have a y. So obviously we still have more work to do. And we're going, in order to need to get a y, we're going to have to get an r squared, because r squared becomes x squared plus y squared. So we will need to square both sides. It will be easier, however, if you move over your x first and then square both sides. So now this will become a 9r squared And yes, you do get to FOIL. Your r squared can now be written as x squared plus y squared. Be careful, you will need to distribute that 9. That's something people forget frequently. Okay, and again, we are solving for y now. So now we'll just subtract our 9x squared over. This is going to be really pretty. Get ready. Divide by 9. And then square root both sides. And yes, you will need your plus or minus. What I'm going to do is square root both sides, and technically top and bottom. Because I can take the square root of 9, that's just a 3. So that way my square root doesn't need to be on both top and bottom. Make sure you have that plus or minus. Oh, and I should have a negative 8x squared. It disappeared when I did my square root. So negative 8x squared plus 2x plus 1, all underneath the square root, over 3, and with a plus or minus in front. So there you go. That's how you convert between polar and rectangular. And our next lesson, we'll start talking about how to graph these things, which will be very exciting. Have a great day. Bye.